Let's talk about the universal law of gravity. Whenever you have two masses near each other, they are going to exert a gravitational force on each other. This will represent Newton's third law. The forces will have an equal magnitude but opposite direction. Okay? Action, reaction. So if we have two masses of whatever mass and they're placed near each other and they exert a force of 60 newtons, what happens if I change the mass or change the distance to the force that they exert on each other? Okay, so let's talk about the mass first. Now, let's look at the universal law of gravity equation. Okay, G times mass 1 times mass 2 over the distance between them, or the radius between them, squared. Mass is in the numerator. So if I increase the mass, that means the force will be increased also. The force and the mass are directly proportional. What happens to the force if I increase the distance? Well, this should make sense, okay? If I get closer together, then it's easier to exert a force, a greater force, on the other mass, okay? If you look at the equation, you'll notice that D is in the denominator, okay? If I increase the D, that means I'm making them farther apart. So if I increase the D, the force will be inversely proportional with a square. So it will decrease. Okay, that's the first one. If I decrease the distance, meaning make them closer together, the force will increase. All right, so now let's apply numbers to the situation. Okay, if I double one of the masses and I triple the distance, meaning times 3, how will it affect my force? First, plug it in. I said mass 1 is doubled. So I'm going to put a 2 in front of mass 1. It says the distance is times 3. So I put a 3 times d in the parentheses and then square. What I like to do now is take all the numbers and put them in front, meaning I'm finding the coefficient or the number in front of the variables. In the numerator, I have a 2. 3 squared is 9. So those are my coefficient numbers or numbers in front of my variables. Okay? I'm pulling those out of the equation because I have a value already for f. Okay, so we're substituting now. I know this whole part of the equation represents the force of gravity, which in this problem is 60 newtons. Okay, and once I get to that point, now I can just solve. Once you get to that, plug it into your calculator and get your answer.